Hello everybody, Mr. Slope Guy here today to help you guys with determining the number of solutions when we're solving equations. So how do we tell how many solutions do we have? Well, we have one solution. If you can solve an equation and you get a number for an answer, that means that there is one solution. Like you solve and you get x is 2 or y is negative 10, you actually solve and get a number answer, then you have one solution. You have an infinitely many solutions, or what's also called all real numbers, if you're solving your equation and the variables drop out. Like you subtract the same amount from each side or you add the same amount to each side and the variable goes away. If the variable goes away and you're left with a true statement, like 2 equals 2 or negative 5 equals negative 5, any number equaling itself, if you have a true statement, that means all real numbers will work, or there's an infinite amount of solutions. We can put in all these different numbers would all work for the variable and be true for both sides of the equation, would be a true statement. Now, you'd have no solution if you're solving and when attempting to isolate the variable drops out and you're left with a false statement. Like if the variable goes away and you're left with something that you know is not true, 5 does not equal 4, or negative 8 does not equal negative 10. So if you get a false statement, that is when you have no solution. So let's look at an example. Solving with a problem, we have equations with variables on both sides. We would start with the distributive property, negative 6 times x, negative 6x, negative 6 times 7 is negative 42. Then we want to get all our x's to one side. So we have a negative 6x and a negative 4x. I like to get rid of the smaller myself, so I would try to get rid of this negative 6x or subtract 6x with adding 6x. If I add 6x to one side, I also need to add 6x to the other. So our inverses of negative 6x and positive 6x will cancel. And on the left side, we're left with negative 42 or subtract 42. And on the right side, I have negative 4x plus 6x. And if I add a negative 4 and a positive 6x together, I get 2x. Then I have all my variables now to one side. So now I want to get the number part to the other side to isolate the x to get the x part by itself. So next I want to get rid of this subtract 2 so I can add 2 to each side. Add 2 on the right, add 2 on the left. Minus 2 plus 2 will leave 2x on the right side. And negative 42 plus 2 will leave negative 40. Then my last step to solve for x, divide both sides by 2, and I get x is negative 20. So if x equals negative 20, that means I have one solution. The solution is negative 20. So I have exactly one solution in this case of negative 20. All right, new example. We have negative 3x plus 9 minus 2x equals negative 12 minus 5x. And I want to start this problem. I don't have any parentheses, so I don't have to worry about distributive property, but I do have like terms. No like terms on the right side, but on the left side I have a negative 3x and a minus 2x. And when I combine a negative 3x and a minus 2x together, I would get negative 5x. Now, I notice I have variables on both sides. I've taken care of distributive property and combining like terms on each side. Now I'm looking to get all my variables to one side. So if I have a negative 5x or subtract 5x, to zero that out, I want to do the opposite. I want to add 5x to it. And if I add 5x on one side, I need to also add 5x on the other. So a negative 5x plus a positive 5x will zero out and leave 9 on the left side. And I have the same thing happen on the right side. Subtract 5x plus 5x will cancel out the x's on the right side. So while attempting to get my x's all to one side, my x's have all dropped out. And I'm left with 9 equals negative 12. And 9 does not equal negative 12. That is a false statement. So in this case, we have no solution, meaning there's no value for x that will work in the original equation. No solution. And so if your variable drops out and gives you a false statement, that's when you have no solution. New example, example number 3. We have 74y minus 8 minus 78y equals negative 4y minus 8. don't have any parentheses to distribute, but I do have some like terms. I have like terms on the left side, a positive 74y and a negative 78y. If I combine those, I get negative 4y. Bring everything else down. Now, no like terms, no distributive property left. I just want to look at getting all my y's to one side. A negative 4y or subtract 4y, to get that to be 0, I'd have to do the opposite. I'd have to add 4y. If I add 4y on one side, I'd also have to add 4y on the other. So on the left side, that would leave negative 8 or subtract 8. And on the right side, negative 8 or subtract 8. So my y's eliminated. They canceled out. And now I'm left with negative 8 equals negative 8. Is that true or false? That is true. Negative 8 does equal negative 8. And so what that means mathematically is we have an infinite many solutions, or we have all real numbers, meaning any real number that we could run into, we could put in for y. If we put it in the original equation, it would work. And we could sit here and try several numbers, and they would all work for y in the original problem, proving that we have an infinitely many solutions for y. All right, so you've seen an example of each kind of problem you'll see on these. So why don't you guys pause the video here, try this one, try to solve, and then determine the number of solutions. Do you have one solution, no solution, or an infinite amount of solutions? Pause the video here. All right, welcome back. We would start a problem like this with combining like terms. There's no parentheses, so we don't have distributive property, but we do have a subtract 7x and a minus 15x. That would combine to be negative 22x. Then I want to get all my variables to one side, so I can get rid of a negative 22x with adding 22x to each side. And when I add 22x on the left side, the x's go away. And when I add 22x on the right side, the x's go away. And I'm left with negative 10 equals 83, which means that is a false statement. If my variables drop out and give me a false statement, then we have no solution. There's no value for x that will work in the original equation. Therefore, it has no solution. All right, you guys, let's try another one. You guys try this one. Pause the video here, solve, and see if you have one solution, no solution, or infinitely many solutions. All right, welcome back. If I distribute the 3, I have 3 times y is 3y, 3 times 9 is 27. Then I want to get all my y's to one side. I have a positive 3y and a positive 12y. A couple different options here. I prefer to deal with the smaller one. So to get rid of this positive 3y, I could subtract 3y on the left side. If I subtract 3y on the left side, I also have to subtract 3y on the right side. So 3y minus 3y on the left side just leaves 27. On the right side, 12y minus 3y is 9y. So 27 equals 9y plus 13. Then I know I have all the y's on the right side. I want to get the numbers to the other side. So now I want to leave the y where it is. The 9y, I want to first get the 9y by itself by getting rid of that plus 13. I'm going to subtract 13 on the right. If I subtract 13 on the right, I also have to subtract 13 on the left. Notice how this makes this nice, pretty railroad track where you can see that you're doing the same thing to the left side, same thing to the right side. So 9y plus 13y minus 13, those are going to cancel. The 13s cancel out, leave 9y. 27 minus 13 is 14. Then I can divide both sides by 9. I get 14 over 9. And we can just leave that as an improper fraction. And just because I get a fraction does not mean the answer is wrong. More and more, as you move further and further into math, you will have more and more answers that come out to be fractions. And you can not change it to an improper. I mean, you can leave it as an improper. You don't need to change it to a mix. Most of the time, 14 over 9 will be fine. So in this case, our variable made it through to the end, and we had one solution. We had exactly one answer. We solved for y was 14 over 9. All right, last one. You guys try this one on your own. Pause the video here. All right, welcome back, everybody. We have no parentheses, so we don't have to distribute, but we do have like terms. No like terms on the right side, but like terms on the left side. Negative 25z and positive 35z combined to be 10z. Now I have a 10z on the left and a 10z on the right. If I subtract 10z from each side in attempting to get the z's to one side, the z's will go away because a positive 10z minus 10z gives you 0 amount of z. 0z is just 0. The z's eliminate and I'm left with the statement 1 equals 1. Is that true or false? That is true. So since that is true, if my variable dropped out and I have a true statement, then I have infinitely many solutions or all real numbers, meaning any number I put in for z will work in the original equation. All right, so that gives you the different options we have with one solution, no solution, or infinitely many solutions. Mr. Slope Guy, OUT, out.